Hi guys, this is Miss Regine from SOAR Educational Services. I wanted to continue working with you guys on these trigonometry problems. And these are problems you might come across in trigonometry class or even in a pre-calculus class. So let's get started. Here's our first one. We have the secant of 5 pi over 3. So remember what you want to do is you want to draw your fourth quadrant. Determine where does 5 pi over 3 lay. So you have, this will be 1/3 pi, 2/3 pi, 3/3 pi, 4/3 pi, 5/3 pi. So 5/3 pi is right here. It is a 60-degree angle. So that's what 5/3 pi would correspond to. It would be a 60-degree angle. And so the side across from a 60-degree angle is negative square root of 3 over 2. Y is negative down here. The side across from the 30-degree angle is positive 1/2. And you have 1 right here. So now if I'm doing the secant is the inverse of cosine. So cosine would be adjacent over hypotenuse. So here we need to do the reciprocal of that, which would be 2. So we have secant of 5 pi over 3. All right, now let's do sine of 3 pi over 2. And I'm just going to use the same quadrant because 3 pi over 2 is actually right here. So again, you just want to memorize where some of these things lay. So 3 pi over 2 is right here. So if I want to do the sine of 3 pi over 2. Now, sine, a quick definition of sine when you have your numbers on a unit circle, and if they give you the order pair, it is just the y value. So right here, at 3 pi over 2, x is 0 and y is negative 1. So sine of 3 pi over 2 is just negative 1. So that is pretty easy to identify. And now they're asking us for cosine of 3 pi over 2. Well, that's just your x value. So that's a 0. All right, and now we have to find the secant of 3 pi over 2. All right, so secant is the opposite of cosine, correct? So cosine was 0, right? But now if we need to do the reciprocal of that, we'll have to put it as 1 over 0, which is undefined. So the secant of 3 pi over 2 is undefined. Now, if they ask us to, just to try this one out, if they ask us to find the cosecant of 3 pi over 2. So that one, since the sine of 3 pi over 2 is negative 1, if we want to flip that, that's just 1 over negative 1. So it's still negative 1. So our cosecant of 3 pi over 2 is still negative 1. All right. So now next one we're going to work on is, tangent of 3 pi over 2. All right, so for tangent, a quick definition of tangent is y over x. So the y is negative 1, the x is 0, so that is undefined. Tangent of 3 pi over 2 is undefined. So when you have 0 in the denominator, that is an undefined value. So here we have undefined. All right, so now we'll move on to cosine of 9 pi over 4. So I will redraw this. And again, you can pause the video, try to find it on your own, and then come back and check your answer. So 9 pi over 4. 1/4 pi, 45 degrees, 2/4 pi, 3/4 pi, 4/4 pi, 5/4 pi, 6/4 pi, 7/4 pi, 8/4 pi is right here. It's when you've gone through the whole unit circle and you're back to 2 pi. And then this is 9/4 pi. So you're actually back in the first quadrant. So remember I said that a lot of these are very repetitive. You'll see like the same answers over and over again. So 9/4 pi is actually a 45-degree angle. So you have to remember the rules for 45-degree angle. The side opposite the 45 is 1. The other 45 is also 1. And then you have the square root of 2. So cosine is adjacent over hypotenuse. Well, just like with the 0, being like undefined in the denominator, when you have a radical in your denominator, you want to get rid of that. You need to rationalize your denominator. So that's going to make it square root of 2 over 2. And if we need to find the cosecant of that, cosecant is the opposite of sine. Now the 45, 45, you see there's a lot of more repetition also in that. So if we're doing cosecant, okay, of 9 pi over 4. So with the cosecant, sine would be opposite over hypotenuse. So does that look familiar? All right, so we want to do the reciprocal of that. So that's going to be square root of 2 for, oh, actually, no. Let me rationalize that. So you have square root of 2 over 2, but now if we need to take the reciprocal of that, so you can flip it, and now the cosecant is actually 2 square root of 2 over 2. Oh, okay, actually, I was right before. It is just a square root of 2. So a lot of extra work that was not necessary because we could just flip it. But that's the final answer. It is the square root of 2. And it's positive because it is in my first quadrant. Okay, I'm going to give you guys now 2 challenge questions. And they're really not that challenging because they're all in the first quadrant. So sometime you are given information like sine theta is 8 over 17 and cosine theta is 15 over 17. I said this one is not as difficult as I've seen some because sometimes you have to decide, oh, well, which quadrant is this in? Well, this is in the first quadrant because they're both positive. So when sine and cosine, all of the functions are positive in the first quadrant. So you just draw a triangle. All right, so sine is opposite of your main angle over hypotenuse. Cosine is adjacent over hypotenuse, so 15 over 17. So now they want us to find the other trigonometric functions. So here you have tangent. So tangent is also opposite over adjacent. So here's our tangent. If we need to find cosecant, you can just flip this. If we need to find secant, you can flip this. And cotangent, we can flip this. So there's that. And then I'll give you one last one. Let me redraw this one. All right, so sine of theta is 3 over 5. And cosine of theta is 4 over 5. And these are also very common triangles. Your 8, 15, 17 triangle and your 3, 4, 5 triangle. All right, so sine of theta, opposite over hypotenuse. Cosine adjacent over hypotenuse. So now if we need to find the tangent, tangent is opposite over adjacent. If we need to find the cosecant, we can just take the reciprocal of this. If we need to find the secant, we take the reciprocal of cosine. And cotangent, we take the reciprocal of tangent. And that's all there is to it with that. As I said, sometimes there are problems that are more difficult where you have to actually find which quadrant it's in. But luckily, all of these were positive, so we didn't have to do that. I hope this was helpful. Remember to like and subscribe, and I'll see you next time. Bye.